Good evening, everyone. Today we are having with us Mr. Ujjwal Gandhi for Masterclass 27. And Mr. Ujjwal Gandhi has a keen interest and expertise in using open source tools to automate spatial data analysis. He has spent 15 plus years at Google building large-scale geoprocessing systems and managing GIS teams. Now, since last few years, he has been focusing on building a learning platform to bridge the gap between traditional GIS remote sensing skill sets and needs of modern spatial analysis through QGIS modules and tools. So, before digging much more deep, I just wanted to ask Mr. Ujjwal Gandhi that what is QGIS or how is it different from GIS? So all the viewers can get to know what they are going to learn in this. So today's masterclass is, as we have in Practical Cities current theme going on as transportation and mobility. So today's masterclass in 27, we'll be learning about how QGIS can be used in transportation and mobility in 4 different scenarios. So over to you.
Yeah, thanks, Jack. It's great to be here. Thanks for inviting me to share experience about using QGIS for transportation. And I will start briefly by just talking about what is QGIS. Many of your viewers might be familiar with GIS. GIS stands for Geographic Information System. It's essentially software systems for mapping. And there are many software that can do that. And QGIS is one such software. But the key difference is it's an open source and free software. That means anybody can use it without worrying about licensing costs, without any restrictions. And that enables a very wide range of use cases for people, and anybody can use that and benefit from that. And I've spent almost last 15 years of my career working on QGIS, and I've also actively participate in the community. So I would love to share more about QGIS and also how QGIS can be used for transportation and how can urban planners and professionals watching this can leverage that. All right, so let me just spend the first few minutes giving an overview of QGIS. But before we learn about QGIS, we need to know what is GIS. And GIS, as I mentioned, stands for Geographic Information System. These are essentially tools for mapping. And you can have these tools do a variety of things. They can work with any data which has location information on it. And you can do a whole range of things. You can do analysis, you can do mapping, etc. And if you think about it, data science, everybody is familiar with data science. Data science allows you to extract and derive intelligence from data sets. And the same thing can be said about GIS. The GIS is a spatial data science discipline where you're able to extract location intelligence from location data sets. So why do we need a GIS? Why do we even care about location? Why can't we just use not use spatial data? And the reason is that all of the natural phenomena that happens, all of our cities, they are on Earth, and every phenomenon on Earth follows this law. This law is commonly known as one of those first law of geography, and it's kind of intuitive that everything is related to each other, but the nearer things are more related to each other. If you think about housing prices, you can think of the nearer houses are similar. If you think about your neighborhood, it's much similar to your neighborhood is much similar than a neighborhood that is much farther away. So if you don't have this insight about where things are, you're missing an important dimension of the data. And that's the reason we need to apply GIS tools to extract this intelligence from this data. And any question, if you think about any question in your domain, which starts with where, you can't answer it effectively without a system like a GIS. Where should we build a new metro station? Where are you located? Where is this traffic jam? Right? All of these questions have a where component in. Where means it has a location attached to it, and to effectively analyze, understand the problem, we need GIS. So what can GIS do? GIS can, of course, view spatial data. So if you ever need to view data in a format like shapefile, or if you have some data about certain locations, you can open that file and view that in a GIS. You can also create data. Many times you have to create this data for your project, and you can create this data. We'll see an example of how we can collect the data using a mobile device and create such spatial data. You can also make maps. If you think about a master plan, how do you create a map like that? You can use a GIS software. You can analyze spatial data. We'll see a lot of examples of that, where given multiple data layers, you can exploit the relationship between them and come up with answers to problems that require those spatial context. You can also do what is called ETL. That means you can extract subset of data, transform it, load it into database. So GIS software allows to build those pipelines. So a bit about QGIS. So QGIS is what you call an open source GIS. That means all the source code that creates the software is completely open. It's a collaborative project. It's been around for a long time, more than 15 years old. It's quite mature. It's very stable, and it has, over the time, it's got more and more features that have been built in. It's also backed by a complete non-profit organization, and the organization has a steering committee and that is elected from the community, and it's a very transparent organization that is helping build this software and make it available to everybody. A key differentiator of QGIS versus other GIS is that regardless of what computers you have, whether you have Mac, Linux, or Windows, it runs on it equally well. And that's really important because if your organization is using Linux, you go and say, I want to run a GIS. Most of the commercial GIS software vendors will say, sorry, our software doesn't run on that. So it runs on any platform, and it also runs on mobile devices. They have apps for Android and iOS. That means you can use QGIS even in the field and collect data, view data, and so on. So if you are excited about this, you can just head over to qgis.org and download the software and start using it. There's no restrictions on that. So you might be asking, who uses QGIS? Well, when primarily there are people who study GIS, who study spatial data science, and these are the people who are the primary users of QGIS. So you might, if you know somebody who has a title like a GIS analyst or a GIS developer or a cartographer, people who make maps, they are the ones who use GIS, and they are also using QGIS as a software in the toolkit. But historically, the largest users have been government. Virtually any government organization that you go, they would have GIS users. And I interact with a lot of people who are in government. They're using QGIS. Indian government especially, they use GIS in every domain. Historically, they've used for like defense and intelligence and so on. Indian Army uses QGIS for their field personnel. Every department, including any natural resource department, management department, they would use QGIS. Also, if you take any earth science or environmental science domain, they are trying to understand phenomena happening on Earth. That means they need to know where things are happening. So any research domain you take, they have GIS users, and you can't really fully understand those problems and solve them without using GIS. So any of these disciplines, they have applications of using QGIS. Planning, we're talking about urban planning in GIS today. So of course, urban planners, architects, transportation planners, they use GIS because they need to understand how their cities are structured and how can we improve them. Lately, there's been a lot of interest in using QGIS from the people who do data visualizations. So nowadays, most of the journalistic organizations, they have a data viz team and they use QGIS. And there are examples of people creating amazing maps and amazing animations using QGIS. And it's very widely used in that community. Also, industry insurance is one of the biggest users of GIS. They need to understand risk in the contiguous space. If you want to say how much would it cost to insure a building, they would need to know what's the risk at the building, what's the earthquake risk, what's the cyclone risk, and this is inherently a very spatial problem. So there's large users of QGIS within the insurance industry and so on and so forth. Almost every place you think they would using QGIS. So millions of users across the world using QGIS. It's a really wide community and a lot of users. All right, so we'll switch topics now and we'll say, how can you leverage QGIS for urban planning applications? The application areas are many. I've listed a few that we'll look at today. One is mobility. Of course, how people travel within cities. how accessible places are, and how does traffic and congestion affect those travel. That's a key application area of a GIS. Similar to, you can analyze hotspots, where what are the traffic patterns. All of those kind of movement patterns can be effectively analyzed. And one thing I should mention is that a GIS software can not only look at spatial coordinates like X, Y, Z dimension, they can also look at temporal coordinates. So if you have temporal data, you can actually visualize and see those patterns change over time as well. Of course, there's for transit-oriented development, GIS is a key aspect that you need to integrate variety of data sources. And this is the kind of strength of GIS, where you can look at multiple layers of data and combine them to see how they fit together. And that's why it's applied, and we'll see some examples of that. Walkability, nowadays, everybody's trying to make cities more walkable. It's good for health, it's good for environment. And to make cities more walkable, you need to understand what are the challenges, what is the accessibility to different places, and GIS can help you determine that. For smart cities, there are many challenges where GIS can help you effectively solve them and optimize some of the solutions. One recent example I came across was where do you want to locate electric vehicle charging stations? And when you ask a question where, GIS can effectively answer that. And we'll see some examples of using GIS to do optimal location analysis using QGIS. So these are just some selected examples. There are many more examples of applications, but I want to run through a few demos. It's because GIS is so visual, and it's always good to see those maps on the screen, and you can see how the software works. So I've selected a few application areas from the projects and from some of my course materials. So we'll go through those now, and I'll give demos of each of those applications. The first application I want to talk about is accessibility of public transportation. So this problem was inspired by a news article I read. It's linked it in the presentation. It's by 𝗨𝗍𝗯𝗍, and they were trying to analyze how good is our metro rail infrastructure in different Indian cities. And the idea was how many people have effective access to a metro rail system, and that helps us answer, where should we build more metro stations? Should we build more metro stations or not? And how do you answer this question? So you can break down the question into kind of multiple dimensions. One is you can say, how many people live close to a metro station? To effectively use a metro station, you need to be close to a metro station. So you can say, in a city, this is where the metro stations are. How many people live within 1 kilometer? You can also say we want to encourage walkability, and say we want to build metro stations which are within a certain time frame of walking distance from a metro station. That means we need to take into account road network and so on, and say how many people can reach a metro stations in a reasonable time. You can also say we want to have an integrated public transportation where people can use multiple mode of transport, and you can do this multimodal analysis where you can combine bus routes and metro routes, and say how many people can reach a metro station using a bus as well. So all of this can be done, and I'll show some examples of how you can do this in QGIS. Of course, a GIS is a software. You can think of a software is like a Photoshop, but you need data, you need photos to edit something in Photoshop. So for GIS to do any analysis, you need data, and the data comes from a variety of sources. One of the most useful sources for you as a GIS user is this database called OpenStreetMap. You can think of OpenStreetMap as a Wikipedia for maps. It's a freely downloadable data set of the world. Again, it's a collaborative project. It's completely open source. You can also think of it as an open version of Google Maps. Google Maps is great. You can view, query the data, but you can't download and analyze it for yourself because it's proprietary data. Versus in OpenStreetMap, you can download and use any of the data. So this is a great starting point for many of the projects. I'm going to show you how you can download data from OpenStreetMap into QGIS. And we'll take some metro station data. We'll take a population grid, and we'll take the street network and say, let's find out how many people live within 1 kilometer station and how many people live within 15 minutes of walking distance from a metro station. We'll not work on the last problem, but again, once I show you how you can solve the first two aspects, the third one can be doable in a similar fashion. So I'll dive into QGIS now and we'll go through this problem. So here's QGIS. When you download and launch it, this is what you get. You have some tools at the top, have a panel on the left where you can browse your computer for data, and here is a blank canvas. So let's open up the project. I have already created a project and I'm opening up. And here are different layers you can see on the left-hand side. Here, this is showing the city boundary of Bangalore city. And this data just comes as a polygon representing the city boundary. So now we want to answer the question, how many people live within this boundary and how many people within the city live within 1 kilometer of a metro station. So before we even do that, we need to know where are the metro stations. Now, how do you get metro station data? You can download the data from OpenStreetMap directly into QGIS. QGIS has, it comes with a lot of features and tools, but also it's got a rich ecosystem of plugins where people can build these tools that can plug into QGIS, can download that, and it'll enhance the functionality of QGIS. So here I'm showing you there's a plugin called QuickOSM. OSM stands for OpenStreetMap, and I'm going to show you how easy it is. Just in a few clicks, you can get any data that you want for any region. And here you need to specify what you want to download from QuickOSM. There's a help button here. If you're not sure what keys and values to use, you can look up, click this button and open up a help page. Say you want to download all the schools. So you can say amenity schools, right? And that will download all the schools in the region specified. So it's as simple as specifying what you want and it'll download. In our case, we want to download all metro stations, and those are tagged with the key railway and station. And say where, and we'll say in Bangalore. Right? So we'll say, give me all the railway stations in Bangalore that are in OpenStreetMap, and I'll just specify I want points, because stations could be points or polygons, how they're represented. We just want the points. I can click Run Query. And this is querying the OpenStreetMap database, which got millions of features, and selecting the right features that match your query, and it's loading them in QGIS. And you can see now I have some points here. You can see I've got a new layer, and all of these points represent the actual location of a train station in the city of Bangalore. And this is not just visual data. If I open up the data table that is attached to this, I can see that each point has its name, a local name, operator, all of this is attached to it. And that means in just a few clicks, I was able to download all the locations of the station. And this works anywhere in the world. So if you're interested in doing the same analysis for your city, you just need to go there, type your city's name, and you can download this data. Now, this one has all the railway stations, including the Southwestern Railways and other stations. So we can apply a filter and you get something like this. So people living in Bangalore would recognize this as the metro rail network. This is the north-south line, and this is the east-west line. Right, so we got our metro station locations, and now we can do the next step. And that is simple. We can do a buffer. We'll say we'll compute all the places which are within 1 kilometer of a metro station. And this is done using a tool called Buffer in a GIS. So you have all the tools in QGIS organized in this processing toolbox. You can access them from here. And there are thousands of tools that come as part of your software. And I can search for a buffer tool, and I can see it's available here. And I'm not going to go through the whole process, but the idea is you can apply this kind of geoprocessing operation on this data and create new data sets. So if you buffer this is what you get. You can see this is where the metro stations were, and this is a buffer. This is all the area which is within 1 kilometer of a metro station. So now we've got our city boundary. We've got a polygon representing all the places within 1 kilometer. And now we need to know what percentage of the population lives within this the red polygon, and then we'll get an answer that what percentage of the population has access to a metro station. Now, how do you know how many people live there? Well, there are many really good data sources of population. Most of the population data sets come like this. They come as a grid of pixels, and this is the data I've downloaded from a project called WorldPop. And you can see if I click on any pixel, it's going to show that in this particular pixel, this is a 100 meter by 100 meter pixel. So in this 100 square meters, 100 meters per centimeter area, 541 people live. And now I have this data, and this is again a global data set. You can download it for your region and say how many people live at each pixel within your city. So now I know how many people live in each pixel. I can just compute the statistics and say, tell me how many people live in this entire polygon compared to how many people live in this region, and I'll get my answer. So I'm going to do that for you. I'll show you how to do that. The tool that you can use is called zonal statistics. And just opening the tool, I'll say, take my Bangalore city polygon, take population there, and compute sum of all the pixels. And that means it's going to give me the sum of all the population within the city. So when I run this, you can see it's computed this, and I've got a new layer. And if I open up the table, you'll see that the Bangalore's population is about 1 crore, 10 million. And that sounds about right. There are about 10 million people in the city. So I've got one piece of my puzzle. I want to know how many of this 10 million people live within this 1 kilometer buffer. So I can do the same again and say, let me take the buffer region and do the same analysis. I'll compute the sum of pixels. Now, if I look at my results, it says about 27 lakh people live within that 1 kilometer zone. So the answer is roughly 27% of the population in the city lives with 1 kilometer, which is pretty good, right? It's still a partial line. There are plans to add more lines. And having lived in Bangalore, I can say that this is actually true. If you live in the core city area, you have a really good access to the metro system. So again, this is a way to use QGIS and open data sources to do a fairly complex analysis, but without GIS software, you won't be able to get this insight. And as a planner, this is a very useful insight for you, where you can say, what's the current status? And you can do what-if scenario. You can say, I want to add a metro line in this region, and that means how do I plan for it? You can check if I add this line, how many people will have access to that, and so on. So this was an example of using open tools. We use the plugin called QuickOSM to download the data, create a buffer, and then use the data from WorldPop to compute the sum of population living there. I want to show you another analysis that you can do to compute something slightly different. And I'm going to show you this region. We're going from Bangalore to Kochi now. So this is the Kochi region. At the base map, I have an OpenStreetMap as the base map here. And you can see this is the Kochi city here, and this is the Kochi region. And Kochi is also one of the smart cities, and they have done a really good job sharing the open data. So they actually have shared the data of the metro network as an open data set. You can go to Kochi Metro Rail website and download this data. And I've just opened up the data in QGIS. So you can see this is the metro line for the Kochi Metro Rail, and these individual green dots are each of the stops. Now, if you want to do a similar analysis and say, how many people live who are in the city who have good access to metro city, instead of doing a plain buffer, just the way we did, we're just computing a circle of 1 kilometer, we can do something more intelligent, something more real world, where we can say, if you're within 1 kilometer of a straight line distance, that doesn't mean you can reach a metro station. within 1 kilometer, because your road won't have a straight road. You need to travel along the road. So how do we compute the travel distance along a road network? And we can also say we want to compute this using for pedestrians. So we'll say what are the regions around the metro stations where you can live and still walk to the metro station within 15 minutes? That'll be a really useful analysis. And to do this, you need to do very complex network analysis. You need to do routing, etc. But QGIS has really good ecosystem of tools that can allow you to do this very easily. So I'm going to show you using this tool called ORS tools. ORS stands for Open Route Service. This is a great service that runs on top of OpenStreetMap data, and it allows you to do routing computation on that. And you can just install this, and it will be available in QGIS. I'm going to use a tool called isochrones from point. Isochrone is the term that is used to identify all the areas which can be reached in the same time. So isochrone stands is a time. So all the areas of within equal time. So I can use this tool called isochrones from layer, and I'll say give your input layer, which is our metro stops, and give some unique ID feed and select the mode of travel. So you can compute all the isochrones using driving distance, but for now we'll use the foot walking mode. That means I want to know what are the areas accessible by walking. And then I can say time 15. That means in 15 minutes, what are areas reachable within 15 minutes by walk along a road network. And all I need is this. I don't have to download any of the data, do anything. So just launch this tool, run this. The request is sent to the Open Route service, and in just a few seconds, you'll get those computations downloaded to QGIS. And you can see now I've got my results, and each of these blue polygons are the regions which are within 15 minutes of walking distance. And you will notice that they're all different sizes. They're not perfectly circle, because if you are living here, there are a lot of streets. It's a city area, and you can live anywhere within this blue polygon and reach this metro station by walk, and you'll be within 15 minutes. But if you go a little bit on the outskirts, you will see here that there are no roads here. So if you are here, if you say live here, you can't reach this metro station. Though it is within 1 kilometer of a straight line distance, you have to take, maybe this road and drive much longer or walk much longer. That means it's not accessible. And that means you get a much more realistic perspective on what population actually lives within an actual distance that they can access the station. So this is a more intelligent way to do buffers, and it's accessible very easily, and you can do this kind of sophisticated analysis. And you can now bring in the population data and compute the same for the 𝗺𝗁 metro rail station. All right, so that was the first example of getting the accessibility of public transportation. And you can encourage you to, if you're interested in this topic, I have added all of this example I showed you. There are step-by-step instructions along with the data set. And if you're interested in that, you can check out those. The first one, the one I showed you about the 𝗺𝗁 metro rail. This is a tutorial here with the step-by-step instructions. If you want to do the first example I showed about the metro rail in Bangalore, you can go to this link and the step-by-step instructions. And this is the link to the article, and this article is taken the data for all the metro cities in India and analyze the accessibility of metro stations. So you can check out that as well. Okay, so now let's look at another application on the mobility side. So we want to understand how the traffic moves in the city, how is the travel time between different locations. And this is very important in planning and reducing congestion in the city. So say you want to know from a given location how far you can travel within 30 minutes during peak hour. And this is not only just using the speed limits, but using the actual time of traffic and actual traffic patterns. So how do you determine that? Maybe you want to determine travel time between two locations and say, when should I travel? Should I go in the morning or evening? What's the optimal time? You can also do analysis like, I have a bunch of people commuting to a certain place. What is the optimal time for the commute? Should they come at 9 and leave at 5, or should they come at 8 and leave at 4? Right. So these are the kind of questions you can answer with the GIS. Another thing very important for planner is that, hey, you built a new flyover. What was the impact on travel time? You you widened this road. Did it impact the travel times or not? You can do this kind of analysis in GIS. Of course, you need data, and this data is very hard to come by. Fortunately, the ride-sharing company Uber, they have open source a lot of this data, or they have 700 plus cities in the world where they operate in, and they have open sourced last 5 years of mobility data. And you can download them. It's a really interesting data. It's aggregated, but it's also real world travel time data. So if you're in any of the cities, you can utilize them along with OpenStreetMap to do this complicated analysis and get a real world travel time analysis. And since this is also historic data, you can analyze what was the impact of different interventions that was happening. So let's look at the demo there. I'm going to show you this one. So this is the city of Bangalore. You can see all the white polygons. These are all the different wards. And there's a location that's highlighted here in red, and that's my office. And I want to use that as an example to say, how can you use this Uber data to determine the travel times? So the Uber data comes in very different slices, what kind of data you want. Here, I've taken the data which is sliced by the time of the day. So I want to know what are the travel times from different regions to other regions at 9 a.m. in the morning. You can download this data and you can open it up in QGIS. And this is what the data looks like. So if I show you this data, you can see there are different sources. These are all the different wards. And it says out of the 9, and this is the mean travel time. That means all the Uber trips that happened over a course of 3 months, that came to this particular location, which I'm interested in, from all over the city, this was the average travel time in seconds. And this is based on the aggregated data of Uber cabs operating in the city. And if I want to visualize this, I can take this data and say, let me do a graduated visualization. So I'll select the blue color ramp and say, visualize this data by mean travel time. And now you can see the visualization where the lighter colors are closer to this, this destination you want. It means everywhere, the further you go, the higher the travel time. And you can see the closer wards have slower travel time and further data. But it's again not perfectly circular because the travel times depend on the traffic, the congestion, etc. And maybe I wanted to say, I want to live within 30 minutes of my office, so I can go every day and reach my office within 30 minutes. So how do I do that? And that means I can use filters, and QGIS allow you to apply filters. So I can say, give me all regions where travel time is less than 1800 seconds, which is about 30 minutes. And now you can see this is the region where, which is within 30 minutes of this office. And this is based on real world traffic data. Without this data, you can't really answer this question because Bangalore has really bad traffic. And the people in Bangalore would recognize this hard line here. And this is a junction known as 𝗪𝗪𝗪 Junction, notorious for traffic. There's no way you can cross this junction within 30 minutes at peak hour. Right? So this data reflects the real world scenario, and you can do this analysis using QGIS. And if you're interested in this data set and how to do more things, I have a lot of material there. The Uber exercise I showed you, it's here. Also, I did this exercise where I took the data for Hyderabad and analyzed that what if you had 100 employees and you changed their office hours, how would it impact the commute time? And you can see there was a directive to all the tech companies to do this so that they can reduce congestion. You can see if you were faced with such situation, how can you take this data and analyze what will be the optimal travel time for employees? And also things like I have 2 locations, what's the best day and time to travel between them? So you can use this data to do this, and there's a post here that outlines how to do that. Right, third demo, it's about walkability. How can you determine walkability of different neighborhoods? here's, as a planner, maybe you are interested in improving walkability of a city. What can you do? Maybe you can answer this question. Say, give me the status, current status. What parts of the city are more walkable? What parts can be more walkable? Then you can design an intervention. You can say walkable cities means you can reach a grocery store, a school, a religious place by walking distance. So you can get those data and say how far they are from each place, and that means if essential services are more walkable, those neighborhoods are more walkable. Also, in certain parts of the country or world, safety is a big aspect of it. How safe are the streets to walk? And I'll show an example of how we can determine that. So again, we'll use OpenStreetMap data. We'll show you some field data we collected in India using QGIS or mobile, and you can do the same for your neighborhood and then analyze this data. So you can collect data on sidewalks, street lights, and etc. All right. So let's do this demo. So this example shows this is the city of Johannesburg in South Africa. This example is taken from their Spatial Development Framework 2040, where they want to take this metropolitan region and make it more walkable. And this is the kind of analysis they were talking about that we want to improve, but they need to understand what's the current status. So one of the easy metric that you can calculate is number of street intersections. That means the density of streets. The more streets you have, the more intersections of streets you have, that means it's more walkable. And there's a global standard of around 100 intersections per square kilometer. And if you have your street network designed like that, that results in a more walkable city. So let's see if you want to do this for the city of Johannesburg. I've got all of the streets in the larger Johannesburg metropolitan area. You can overlay a grid like this. It's a 1 kilometer by 1 kilometer grid. And then you can count the number of intersections. And if you do this in QGIS, you get a result like this, where, and I just want to overlay the places so you can get some context. So you can see that the red color grids are the ones that have high number of intersections, and the blue ones have low number of intersections. And you can see this is the city of Johannesburg. The core city has good walkability, but as you go outside, you'll see that the walkability reduces. And there are other towns like Soweto, which have got much lower walkability. So as a planner, you can look at that and say, let's figure out what do we do to improve walkability in those regions. So, and this is again, because this is all based on open data, you can do this in any part of the world and determine the walkability of your city. I also want to give an example of walkability of in the context of safety. So I mentioned QGIS also comes with a mobile app. So there are two apps. One is called QField. Another app is called Input, INPUT. So you can use any of those apps, install them, configure them, and then take them to the field. And this was a survey done in Chennai. You can see this is a block of the city where we went out and collected the data on streetlights. So let us see what the data looks like. So you can see at each point, you can say what's the condition of the road, is it working, not working, street light, and then you can take a picture. This all again comes to QGIS, and you can take the location of the street lights, and you can walk around and collect this data for all the where the street lights are in the neighborhood block, and then which are working, not working. And you can do it very quickly. And the data, if you have internet connection, it syncs to QGIS via cloud service so that you can have somebody in the field, you're sitting in the office, and your data streams to your desktop. And you get a data set like this, which you can then style it and say, this is what it looks like if you say each street light has a view illumination radius of say 30 meters. This is where the gaps are. There are patches of street which are not lit up, and that means this is where the gap is. If you want to make your street safe at night to walk, you need to illuminate them. And again, because this is all done in the GIS, you can play with this and say, what if we use a larger illumination radius, how the situation changes. and that allows you to analyze this data in a very quick visual way, and you can improve the walkability of the city. All right. Next one, we have an example of how to determine the optimal location of a new facility. And this is known as a multi-criteria overlay in GIS terminology. So I'm going to show an example how to do that. So here's the problem statement. Say you are interested in promoting bicycling and you want to improve the bicycling infrastructure. How do you use GIS for that? So first, you need to visualize what's the current infrastructure like. Where are the bicycle parkings, where are the bicycle lanes, and where are the gaps? You can identify that. Another issue might be that bicycle theft could be a problem. This problem actually comes from an article I read in London that bicycle theft is a #1 problem, and people are really concerned about taking the bicycles out because they're worried they might get stolen. So if you want to promote bicycling, you need to make your parking spaces safe. So how do you do that? Where do you put additional parking spaces? Also, where is the gap in surveillance? You have CCTV cameras. Are they covering all the parking locations, and can you improve that? So those are the kind of questions GIS can help you answer. And of course, you need to know about where are the thefts happening, where are the existing facilities, and then you can do this analysis. So I'm going to show a demo of that. This is the city of London. You can see on the map behind, this is the largest city of London, and this is one of the boroughs, like a ward of a city. So it's a Westminster borough, and we want to analyze, say you are in charge of improving bicycle usage in this borough. So we can do first, look at the crime bicycle thefts, and this is a heat map of bicycle thefts. I have a detailed tutorial and walkthrough how to create that from the source data. You can download the crime incidents, filter it to all the bicycle thefts, and create this hotspots. And you can see now where are the hotspots happening. And it's kind of interesting to see that in context of the base map, like where is this hotspot? And you can see that this is a park. In the park, maybe a lot of people are taking cycles and they're getting stolen. There's another hotspot here. And this one is a college. There's a university here, and maybe a lot of students using bicycles and things. So you can kind of just spatially see where are the hotspots and where are the problems that need to be addressed. But we can do a more a proper quantitative analysis of how to improve the bicycle infrastructure. So another thing you can do is look at where the bicycle routes are. So in London, there are certain routes designated as safe for bicyclists. This is what most people use. So this is all the routes which are bicycle routes. You can see most of the hotspots are near the bicycle routes as well. You also need to know where are the existing parking facilities. And this is, again, the City of London is very good at sharing this data. You can download and see that each individual triangle is a parking facility. Now, if you look at this hotspot, you can just see there are no parkings here. Okay? There is no parking here, and a lot of cycles has been stolen, and that could be the reason. Maybe you need to build a parking facility there. So how can you quantify that? How can you identify that hotspot? So first, we can extract the hotspots. These are the hotspots we have extracted as a polygons, and then we can say buffer. Give me a buffer around the bicycle routes. That means I want a parking which is close within 50 meters of a bicycle route. People are not going to go too far away from the route. Maybe they need a break, or they need to visit somewhere. They need to find a parking which is along the route. And then you can say do an intersection of both the hotspots and this buffer. That means these are all the polygons which are both in a hotspot zone, and these are within an existing cycle route. So these are good places to put a parking spot. But we don't want to build a parking spot which is already close to another parking spot. So we can buffer the existing parking zones and say discard those areas. So you can use a difference tool in QGIS, and then this is what you get. that these are the regions which meet all the three criteria. They are in a crime hotspot. They are also within 50 meters of a bicycle route, and they're also not close to any existing parking lot. And as a planner, we can now take this and say, we really need to build a parking facility, and we need to increase the surveillance here so that we can improve bicyclability and people feel safe getting bicycles to the park here. If you're interested in this, again, I have all the step-by-step instructions on how to do this using open data in QGIS at this link, so you can go and find them and do this exercise yourself. All right, we come to the last demo I have, which is the route optimization. And this is something that people, city planners, need to do this, but till now there were not really good tools and instructions available to how to do this. So this is something I've developed recently, and I've published this so you can see how to do this. So this is the problem statement. Say I want to build a new facility. Where should I put this in the city so that my cost is minimized? And the cost could be travel time, could be the fuel cost. It could be any user-defined function. So I want to minimize that cost. Where should I put the new facility? And GIS allows you to do this. This is called a location allocation problem in GIS, and you can use that problem to solve a method to solve this problem. What you need, of course, you need your street infrastructure data. You need to know where the demand points are. So in this example, I'll show you how to locate a new waste management facility. So you need to know where are the existing waste management facilities, where are people coming to use this facility. So the specific example I'm showing is a waste drop-off facility where this is the city of Cape Town. They have a system where a certain kind of waste needs to be dropped off. So people get the waste in the car or trucks and drop it there. And so you need to know where people live and where people need to access these facilities. So given all of that, we can analyze where do we put this new facility that will optimize the travel time of all the people. That's the last demo. I'm going to show this one. Right, so this is the city of Cape Town. A bit of context on what you see on the map. You have all these different polygons. These are all what they call refuse collection beats. And this is a unit of waste management. And I've taken each point as a centroid of this, indicating a demand point. That is the center of a neighborhood. You can, right, for this analysis, I'm assuming equal population distribution. But if you have different population, you can assign those weights, and this analysis will use that. And you can see that these are the existing facilities. So these are all the all the drop-off facilities in the city. And that means you need to go to one of these facilities to drop off a waste. And just by visually looking at this, you can see there's a gap in this region. To live here, you need to travel very far. So maybe the city comes up with a proposal that let's build a new facility here. And maybe there's a competing proposal. They said, no, we should build a facility here. Now, just visually looking at, can you tell which one is better? What will help people save time? You can't. It's you need to understand how, along the route, what is the optimal route from each place to this facility, what's the travel time, etc. But you can use QGIS to do something called a distance matrix. And what this computes is you can give it a road network, give it a cost function, and it'll give you routes from each point to every other point. And then you can filter that to come up with something like this, where this is the closest facility from each of those demand points. So if you are here and you need to drop off a waste, this is along the road network. This is the closest facility. You can see this is for the proposal one. If you build a station here, this is where how the travel time will look. But if you build this new drop-off facility here, the people need to travel here. So these are the kind of travel times there. And you can now open up and compute a summary on that. So I can take my proposal one and say, what is the total distance that people need to travel? And I'll divide by 1,000 to say what in kilometers. So sum total of 2,771 kilometers is the total aggregate distance that people need to travel if you build a station here. And I can similarly change this to proposal 2 and say, show me the same for proposal 2. And now it says 2752. That means it's a lesser distance that people have to travel if you build this tool. So the proposal 2 is better for travel times and will result in a better access to the facility. So again, using open data sources, tools like QGIS, you can do this very sophisticated optimal analysis to locate such facility. And again, I have linked to the instructions if you need to do this. This is the tutorial that explains you exactly how to do this. So that's it I have for the demos. Hope you got some inspiration on how GIS and spatial analysis can help you as an urban planning professional, and hope you'll be able to use it and apply it in your work.
Thank you for this wonderful masterclass. Actually, we had a lot of questions while seeing this, and a lot of viewers would be having this question. As I'm also keen to learn QGIS and analysis experience. I had two questions which are somewhat related to the overall QGIS as a topic, not specific to transport and mobility. First question is, how can we use QGIS in the current COVID management?
So as you saw last year, that when COVID happened, the location data was at the forefront. People were always looking at where are the cases coming from, where are the containment zones, where are the health facilities. So the location became really important, and this is really the important concept in public health and GIS. So there are a lot of applications of GIS and QGIS also in public health. So one of the things that you need to understand is where are the current scenarios, what is the current scenario, and how it is changing over time. So people have done, for example, you can take all the data that being shared and say, for each zone, for each ward, what are the case numbers, what are the testing numbers, and you can see the progress over time, and you can track those in relation with the health facilities, and you can say, analyze, are there enough health facilities? There are also, for example, the government of India has shared the location of all the vaccination centers. You can do a similar optimal analysis and say, this is where the population is. This is where the vaccination centers are. Are there gaps? Can we plan more centers, or can we relocate some of those centers? So there are many opportunities for applying this concept of spatial analysis into public health, especially in COVID. And I see a lot of people doing that. Word of caution though, the GIS community, when COVID first happened, a lot of the GIS people started jumping in and saying, we'll apply that. But there are a lot of nuances to doing this right, because it's got a lot of implications on what data are we trying to share, how we are trying to visualize this data, and there is a right way to do it and there are wrong ways to do it. So the right advice for this is, if you're trying to do any COVID mapping, partner with somebody who understands that from an epidemiology perspective. So, and work as a team, and then you can bring in your expertise in location and map that. Doing this in isolation will result in your visualization or analysis may not be appropriate.
Thank you for this. I just wanted to know what is meant by spatial in terms of thoughts and in terms of data.
So the spatial, the spatial word refers to space, and typically the domain that we study GIS is referred as geospatial. That means geo is Earth, so location on Earth. That's what geospatial is, and this is just the name of my company's Spatial Thoughts. And the way I came up was that I started a blog 15 years back, and I was like, what should I name my blog? And because I'm from this domain, I try to apply a spatial angle to every problem. And that's why I named it the Spatial Thoughts. And now when I started the company, that just name that carried on. So the idea is that, the spatial thinking is what I teach in my courses and classes is how to apply spatial thinking principles. How do you incorporate location data in your problem? How do you effectively apply those spatial thinking methods to solve a problem? And this is what the Spatial Thoughts.
So I think from this masterclass, people would be interested to learn more about QGIS. How can they learn more?
Sure. Let me show you my website. It's called spatialthoughts.com. And what Spatial Thoughts is, it's an online academy for geospatial technologies. That means you can come and learn QGIS. I teach a lot of other cloud technologies. I teach programming. And the main offering that I have is live online classes. But one of the things that I'm very particular about and I'm really passionate about is sharing a lot of open learning materials. So if you're on the website, there's a student corner and there's a section on learning resources. And this page has literally hundreds of hours of learning material that's been created. It's completely free and open. You don't need to pay anything. You can just go and learn. And I want to just go through that. So the first one is the QGIStutorials.com. This is a site that has got 40 plus tutorials. I referred to it multiple times in the presentation. And you can come here, pick a topic or just start from the top and work your way down. And once you complete this, you'll really know what QGIS can do. All the tutorials are completely free. They're also available in different languages. They are translated into 10 plus languages. They're also used by many, many universities to teach GIS. So it's a great resource. This is something I spent a lot of time creating. I still spend a lot of time curating that. So this is one of the resources you can use to start learning. I also have all my courses where the material is completely open. So I have about 4 QGIS courses, starting from spatial data visualization and analytics, advanced QGIS, customizing QGIS, automating workflows with QGIS. So you can take this course. These are full-length 8-hour courses, completely free. You can come in and learn that so to build your skills. I also have a YouTube channel that I post lectures and tips and into projects. Also have a blog. I give a lot of talks like this, and this page has a list of all the talks I've given. So if you want to learn about a certain topic, you can go and visit that. I also have a newsletter. You can come and subscribe. I send it out monthly, and I give a lot of tips, a lot of pointers to free learning materials. So this is the page that you want to visit, and if you want to start learning about QGIS. Thank you.
Thank you, sir, for this wonderful masterclass and lots of learnings that we got in this today's masterclass. We all will be staying connected. So stay safe and be healthy.
Thank you. It was a pleasure.